Hello, pokalbiai apie kokybę listeners. Today we're going to have an episode about IoT and hardware testing.
And as you can see from our changed background, we are not in our usual place where we record this episode. So we are now in Latvia, in the city of Riga. We have been invited here to talk with our guests.
So today we have two experts joining us and talking about IoT and hardware testing. And we can start from Matiss. Please introduce yourself to audience.
Hello everyone, my name is Matiss. I'm software testing engineer, but today we are going to talk more about hardware testing.
Thank you. And then we have another guest, Artūrs. Could you introduce yourself?
Hi everyone, I'm Artūrs. I'm a software quality engineer and specifically when it comes to IoT testing.
So, and we're going to be starting with the main topics. What is the hardware and IoT testing? We need to explain that to our audience.
Hardware testing, we don't deal only with the software. It's sometimes that usually in IT that the things that products that we test are not only software products, and it sometimes comes together with a box which runs the software. So it can be a gadget or sensor, it can be basically anything that runs on battery power, can be network device, and can be also something heavier like a vending machine, for instance. Then basically this hardware is running the software, and it kind of extends the software testing.
You mentioned about the hardware and IoT. So IoT, as I understand it, is the Internet of Things, right? Yeah. So what is different when you're testing IoT compared to when you're testing like a hardware gadget? What additional testing or processes do you need to do?
So basically, when it comes to IoT testing, you have to understand the capabilities of IoT device before you begin any testing. You have to understand the needs of the client, what we need to achieve. And basically, when we understand that, we can move on with the testing process. And basically, IoT device consists of hardware, sensors, and communications. When it comes to communications, we have to understand the protocol, what are we going to use, and how it's going to work in sync with all the network, brokers, and cloud services.
Can you give an example of IoT device? So we could be maybe making it as an example, how would we then testing it and so on. So it would be easier to imagine what are we talking about.
Like a smart light bulb?
Well, we can start with everything that is in your home. Basically, any device that you connect to the internet can become an IoT device. Here we need only, to test this. If it's a regular device plugged into wall outlet, it's just like another computer. But mobile IoT devices, which we test here, are more or less like sensors. For instance, I guess Artūrs, you can mention about utility sensors, right? So
utility,
electricity meters, water meters, gas.
Oh, so
oil.
Those smart meters, which if I have them, I don't need to go to that underground to write down the numbers every month. So
exactly.
So they are also considered the Internet of Things, right?
Yeah.
Okay.
Actually, in every country there is a provider, usually for utilities, and these providers start to migrate from regular meters to smart meters, and then it becomes an IoT problem. And then you need SIM cards, you need to broadcast this, transmit the data to somewhere, to the platform. It's usually not in reach, you can't just plug it into internet wire. It's usually remote, maybe basement, maybe some kind of far away place,
So the device needs to be battery oriented.
Yeah, and also it needs to reach out from that remote place. So then customer needs to decide whether it's going to be something with SIM cards, additional cost and all that. Plus, as you mentioned, Artūrs, it consumes battery and needs to stay there unmanned for years. So we need to test that.
This utility device, smart electricity meter, right? So is it does it enough for the device to be considered the IoT device if it's connected to the internet in some specific way, or there are more parameters or more requirements? Yep.
I guess you could say it's an IoT device if it's connected to the internet. But it also needs to be about sensors and how it's going to communicate.
In utilities, it's not, there is a sensor, but there is also a gateway. And
there's a gate.
sometimes it's less costly to bridge all sensors to one device that you pay for, internet, yes, and then transmit through that. That's kind of a topology of devices together. Yeah, so companies try to save money. They don't buy individual sensor and attach to individual meter, because you go to regular Soviet building with 5 floors and there are like 90 of these. So you don't buy 90 SIM cards for one building. Yeah, so you bridge them together and try to figure out some architecture. And you want to interface the sensors. Sometimes, as Artūrs said, it's communication, and each sensor manufacturer or vendor produces different protocol. Yeah, there's proprietary, and our challenge sometimes is to link together all these sensors with different ways how they communicate. Sometimes they're legacy, sometimes they are quite modern, but they all need to go through this one device and just send data in the same way.
What are differences between testing different types of hardware, and maybe there is some kind of process or widely accepted groups where you could put one hardware devices and not another ones?
Like category.
Like categories, right? That's the word.
For instance, here in TestDevLab, the last word of TestDevLab is lab. So we have laboratories, and we split those laboratories per hardware functionality. For instance, we talked about power and energy. So we have a laboratory where we test hardware power consumption, like a separate thing. Then it's about hardware networking. Yeah, that's a different function. And for that, we have another laboratory that can imitate the environment, the network environment around device. And for hardware, as we talk about more or less gadgets, we can talk about like static and mobile ones. So here, most of the customers are requesting to test mobile things that are inside something like mobile devices, things that are remotely located. And and the third thing that I wanted to mention from laboratories is location and GPS. So a lot of these devices transmit their location. Therefore, we also have a laboratory box called Faraday box from the physics. Yeah, we place their device and we don't have to move around. So we may basically get this environment static, yes. And the mobile device can be put in the box. We can attach a special device radio that transmits GPS to it. So I would say I'm right now running in Ventspils or in Kaunas. So I'm actually in Riga. And then in the same box we place the battery box. We place the network router. It's all isolated from what's happening in reality, but we kind of imitate this environment. So with software, we could do this in simulators and emulators, but with hardware, we can't. We are too much linked to the physical world. And then we try to trick this so that we can have a box for that device, and it's all happening there.
So you can imitate GPS signal?
Well, yeah, it's doable.
But it's pretty hard because like the satellites are sending
Yeah.
the signals, and you need to triangulate between multiple, like where are your positions actually?
Yeah, we could categorize hardware like, like small devices, like battery powered ones. Then there could be bigger ones. I'm talking right now about small ones. Yeah, usually those are something that we can place within meter by meter, one square meter box. Yes, so sorry, it's 1 cubic meter box. Yes, that applies to drones. That applies to phones. Also, anything that has GPS. The hardest is to trick phone. Yeah, it has assisted GPS. It has these weird features that get your location from whatever you're connected to. Let's say you don't receive GPS signal in this building. It's 1 meter wall, yes, but it gets from internet, from the nearest cell tower. So all this has to be kind of, silenced, and then we can introduce our signal, and then it picks it up and works like that. We even tried once to imitate like a base station, cell tower. which is like emitting in 1 meter. You don't, you need special license to emit radio signals. That's why it has to happen in a box. So yeah, then this phone could pick up this signal from 1 meter, and then kind of, well, at least you could send SMS over it. Like this is kind of
So you kind of build a
experimental
fake
thing.
network tower, your phone connected to your
Yeah.
fake provider, right? And you
Yeah.
send the messages over that
With
protocol.
with the first or second generation mobile network, the phone is pretty dumb. It actually, you don't need to swap the SIM card. It connects to the nearest with the tower with best signal. Yeah, you just need that tower to emit the right
Frequency.
brand,
Yeah.
the right provider thing.
But it's kind of interesting when we test software, and in some of the environments we want to test all the integrations, right? With the payment system and so on. We can mock it at like a development stage, but we want to test it with actual integrations. And I guess with all the GPS things, you can mock that information, but at some point you will need to test it in somewhat a real environment where the GPS signal will be like emulated in that environment, but it will be like the hardware will be used for actually to find out the GPS signal.
Exactly. Sometimes we can imitate GPS signal in software, but we can't imitate a situation when we get under the bridge and this hardware produces differences in the low level, yes, and then it produces different weird outcomes in the software, and then at the last we take taxi, and then it just gives us a bill for 50 euros when we drive 2 kilometers or something like that happens. Those situations we can try to imitate, yes, so that we can get a better software at the end. Well, also a better hardware. Well, we don't usually work with the vendor. How Samsung built the phone it's that phone. We can't do that, but the software can be worked around some problems or improved. And then we can also talk about IoT part. So with the same boxes, we can put there in the energy meters, and we have energy meters that are wireless sometimes, like signals like VM bus, yeah,
M-bus.
those, and LoRa. Those signals are all radio. So sometimes you don't need to put that gateway that collects data from readings from meters close to them. You can put them in a distance, and then you need to check that from this basement it can reach out to the gateway, and gateway could reach out to tower.
Yeah, for example, let's simulate the situation. We have the building and we need to collect the utility data. Basically, you come with your gateway, and with VM bus protocol, it transmits radio signals, and you can actually capture them. You need to actually decode them as well. And after you decode them, you can actually see the current usage of water. And after that, you can actually use it to understand the current usage, and you implement that logic into understandable language. And then for for example, cloud, you need to use your cloud to actually see the data from the gateway.
A lot of data transformations happen there in the middle, and a lot of data get lost.
So you do need to test transmitters in lab environment as well. Like, can it go through concrete, and how much floors can it go through, and like what thickness? If there's someone have some kind of insulation on the floor, then it means that it doesn't, like, it's blocking your signal.
Well, yeah, actually, one of the, some engineers interpret IoT and IoT technologies, protocols, and related to that, specific to that they should do that all. Yes, why wouldn't we use just broadband internet LTE everywhere? Why we use LTE for specifically machines? It's because it's designed to go through thick walls, get out of basement and all this, yeah, and reach huge distances, like LoRa, for instance, LoRa protocol, yeah. So we try to test that, and we need here something to like gear to provide these environment conditions. And then we do a lot of things. We just put devices in cookie box, which is out of metal. We create Faraday cage effect, and then we can also place it behind walls and try to draw distances, and then measure in meters how far it gets, and calculate how much data gets lost, the signal interferences and all that. If that's needed, yeah, that's kind of advanced testing of hardware. That's already bordering to laboratory works, yeah. But in general, what we need to do is we are sure that it functions, that all this solution functions. And sometimes we get customers who are not currently like hardcore vendor would ask the laboratory thing, but the customer who would like to use it and would like us to test their use case with, for instance, this set of sensors, like for instance, Artūrs is given 10 devices, 2 gateways, and choose which gateway is better. Yeah, so our task is to actually use the technology, understand it, configure it, because no one will kind of tell you how to do it. You need to do it and then provide customer the insight.
Oh, even that way.
Yeah.
So they don't give you the instructions
Well,
like we are going to use it that way, tell us that it works. No.
If the customer is a vendor, then yes, of course, we ask for everything, yes. But sometimes it happens the customer is also a consumer. We are taking the customer side. We are trying to be the customer and then report to customer if it's okay or not.
Usability testing in sort, right?
Can you explain me 3 concepts I heard? Like I'm not really clear. What is a gateway?
Yeah.
In this IoT? So basically, if I understand correctly, right? So if I have some kind of IoT device and it cannot transmit to the network, like to the cloud or whatever, but it can transmit to some kind of middle station, which you call a gateway.
Yeah.
And that gateway can be connected to multiple IoT devices, right?
Yeah. Basically, yeah. So we have one point that connects to internet. That is the gateway. And then we have different sensors. Let's say they don't have internet protocol. They use some kind of wireless protocol, but it's not like directly internet. Yeah. So they are not even linked to internet. They are linked to this box. The box converts their protocol to IP protocol and then transmits over the internet. Yeah. So that is the gateway. And these gateway boxes tend to be quite complex. Yes, they are like Swiss knife for like supporting 4, 5 protocols, maybe wireless, maybe wired protocols like Modbus and all these, like in industry. Yeah, so and Artūrs sometimes does this thing like configures like the gateway in a specific mode, and then the challenge appears for this gateway when you need it mobile. You know, you can just plug in a Wi-Fi router in a wall and forget about it. But if this gateway has to be also mobile, it needs to consume as less energy as possible and at the same time collect all this data, transmit everything. Yeah, so that's a specific, very specific device behavior that they have to design it for. And yeah, for instance, when we talk about IoT devices, they usually sleep. And battery consumption especially.
In a sleep mode.
So when you try to measure like amperes, you know, you take the multimeter, you measure amperes, like it's 0. It's always 0. But how you measure it over 10 years when it's always 0? It's something like nano amperes or pico amperes. So we need specific gear to measure how much it consumes during the deep sleep mode. And then it wakes up. Let's say once an hour. It wakes for energy readings. We maybe do it once a day. Yeah. You know, we lost it in Monday. We can get it on Tuesday, but still, it just wakes up once a day and it needs to broadcast the data. Yes, and that's because the battery is designed to last for like 5 to 10 years. Yeah, and when the battery dies, it just dies. Depends on battery chemistry. Sometimes it just gives you like 99%, 98%. You know, you can just measure it for a while and, you know, extrapolate when it will die. But some of the batteries just are okay, and then 1 hour before they die, they just do some glitch, and then you need to catch that. And that's kind of specific to batteries. Yeah. Because for Artūrs, it was the case once. Yeah, you can tell a bit about batteries on
yeah, there was the situation when we had the building and there was electricity meters, and we had to capture the data from electricity meters, and actually the gateway was powering one of the components, and that gateway was battery oriented. So basically the battery was powering one more device, and what it means basically, Manufacturer said that this battery is going to last 5 years. And when we actually added one component, it's not anymore the case. So our battery just died in like 3 months. And no one had the idea it's going to happen, but it happened. And basically, when we realized that battery died, oh well, we changed it. It was quite easy.
But then you changed the battery. So if you didn't disconnect that component, which was also draining, it means that you need to do that every 3 months, right?
Not really, because when we realized that it's not going to work, we changed the whole architecture, how it works. So
Well, sometimes we also need to contact the vendor. Like when we are testing, you are testing, for instance, open source software. It runs on, for instance, a browser. You can contact the browser, Google or not Facebook, but Firefox directly, file a bug to them. Sometimes here we also need to report this issue to the vendor. Just that it's not by design working as it intended.
Oh, so you send.
It's not like
I
ground
bought
rule.
a device, right?
Yeah.
Your user manual says like that and that, but sorry, that's incorrect.
Exactly. Well, that's kind of depends on agreement. So sometimes we do also this on behalf of the customer. And also that was just like field testing, what you mentioned. Yes, sometimes we needed to actually be in the field. We needed to go to a specific location, place this entire setup and test it before it's going to be released. So it's like a pilot project. And then in that case, I can mention that it's not the only IoT project where in test develop we do I would not say it's mobility, but it's actually field tests, including the location. Sometimes you need to drive around. I think there is a wild idea about creating a bus, like a Ghostbusters van, that has all these Starlink satellite, whatever receiver and all that, and it's gonna go around and capture some mobile traffic. But more closer to Earth, we are testing like scooters, specific modules that are helping you on bicycle or scooter, not like fitness apps, but tracking some data from that, and then the person needs to actually ride it to test it. Yeah, so it can't be like, you can't test it without actually trying it out. One example I can mention, when you imagine how would you test your smartwatch, like a fitness app, for instance. Of course, you need to measure pulse, so to know that the pulse measurement function works. Yeah, it might work with simulated signal, but then at the end it needs to also work on your arm. Yeah, and in that case, for instance, we can place like a swinging thing that imitates you walking, for instance. Put that smartwatch also in Faraday box and fake GPS signal. Yeah, so we try to be creative around what we can do, but we first try to, create these labs based on function, like location, battery, network things, and then we can do combinations. And lastly, the highest stepping of hardware is to automate all that. So that
from a process perspective, how does your process look when you do hardware testing? So do you have requirements, test cases, that kind of thing? Can you compare that?
Yeah, so if we talk about process and formal part, actually testing has a process, and that doesn't that's not quite different from hardware to software. In the testing process, you have test plans, you have requirements, documentation. The same steps apply. Yeah, you can even I think even in ISTQB certification, you have something for hardware. I guess it depends on the physical execution, the real execution of the testing. Not much of this like formal part, but the actual how it's gonna happen. And that, I guess, is the most different part. If we are not talking about like certification of hardware, usually in test develop we are doing validation, right? We are testing to check if it works, to not verify, but validate that it works and all that. But we are not giving a stamp here, this ISO. That we are not doing. Yes, there are different other companies who are certified to do that. And another important thing about hardware particularly is that we are not doing these aging tests. Like there are specific companies who do 1,000-time drop tests, or like hinges, you mentioned it, yes, like just open close it for a million times. That particularly we don't do. In some cases we can do it, but we don't usually do that. And also for electronics part of the hardware, there are these boxes where you can place in device. It ages in oxygen and temperatures and all that. That laboratory gear we also don't have, and we are not yet planning to expand on that. Yeah, it depends on the project and the customer request. Sometimes if it's feasible, we can extend it. But yeah, usually it's, we start with the offering, what we can do from the perspective of existing gear and processes like I mentioned, laboratory test processes. And then we can extend on something like advanced.
The process of testing hardware and software is pretty much the same, right? So you get something, right? You create a test plan, check the requirements, right? And these different laboratories and like field tests, they are part of the actually testing, right? Like you created a test plan for your hardware, and then you decide like this is going to be the first test, and I don't know, laboratory 1, and laboratory 2, and then you're going to outside, right? And then here is your result.
Yes, usually I would split these kind of involvement in the project in 3 levels. Usually we offer first like a pilot. Yes, sometimes it's the customer is interested what we can do, what we can offer, and we offer like a pilot to showcase how we would do it. We create like a test plan also for that. We show what laboratory equipment we could use against that test device, and then like our options, and then we can execute that pilot test upon like further request. Also, we can do a bit extended testing. Like we talked about sensors, we talked about we didn't cover the other part where the data land and what is it done with IoT data later. That's important to also notice. Like of course we kind of went with the very basics of testing. Let's say a complex. Usual complex would be smartphone app plus gadget. Yeah, that we can test together, and that's a very popular thing. But then we can test functionality, and later we can test performance. So all these things we mentioned about GPS, about battery network are a part of this non-functional testing, which is performance tests and all this. And that's kind of a bit advanced setup and a bit more costly, of course, than regular functional. That would be the next second step. The third step would be the customer says, I want it all. I want end-to-end. Yes, something like that. So end-to-end means from one end to another end. So we can't just isolate ourselves from the cloud. We need to also get the data out of the other end after it's being processed. Yes. Whatever.
So you need to do like what the software testers do. Do you need to set up the
Basically,
environment?
we combine software and hardware testing in that case. So that's the most expensive thing, yes. So it involves testing or simulating the data sender side. It involves the network component. It involves cloud and also the services that, let's say there's an API to get your data. There's a dashboard. There's maybe some app that you can use to access the dashboard. So all this kind of brings together software and hardware testing in the same solution. So that's the most kind of complicated thing. Of course, the complicated things start by manual work. Yes, that's at some point you need to understand the product, as you said, yes, and at some point you just need to go through it by yourself to understand how to later automate it. Yeah. So that slowly goes to that. So
basically, you put on a hat and of an early adopter, right? And there is a new device in the market which nobody knows. So that's you probably, right? Yeah, and you try to use it yourself. And while you're trying to use it, you get some kind of results, and then that information is used for automation later. But getting back to the software and hardware testing, so can you say what do you think? What is the differences there? So except that you need to physically have, like, I don't know, boxes, Faraday cages, and put on the fake devices and simulate fake, I don't know, if it's electricity sensor, probably fake electricity signal. If it's water sensor, fake water sensor.
It's harder to mock those.
Harder to mock, right?
I think it is easier to test software in some case. It's also cheaper to do rounds and rounds of testing of software. You can easily delete code, commit it, and offer the next version. But for hardware, it needs to go through so many things, including building something physically. So the next version after the testing, it's very expensive. You have to wait for longer for that, and there's less room for error in that. Yeah, if it makes too much errors, it gets too expensive to build that.
As a software tester, I was complaining how hard it is to create test data. Now I won't.
Yeah, that was my thought, like emotionally painful, like when you build a lab trying to test something and they say, okay, this device doesn't work out, and they send you another device and you need to build all the lab from scratch, and you have to just put this one some kind of in the dark room and forget about it. Doesn't it hard that I put so much effort and now it's gone?
Yes, it's very creative work actually, and with creative work it's so usually like that, you throw it out and forget. But these setups we build, they are like templates, yes, and that's why we try to offer a template of this laboratory so you can pick it up together for the next job.
You just need to rebuild it.
Yeah.
I mean, it's emotionally exhausting, we know that, but it is what it is.
But actually for the customer it's much more painful when to discover that there's a flaw in technology. Like basically you already build a prototype and you're almost like this close to market, to releasing it to market, and find something there. That's I guess for customer it would be heartbreaking.
It's better than finding it out when you have 100,000 devices created.
That's why we are here. That's why we offer this.
But maybe you don't have it as attachment to money compared to something that you created as a creator. And probably in your house you have a storeroom for everything you can't throw out because you have an emotional attachment to them.
Well, actually, I don't have that much at home. If I would have the storeroom, I would probably store robots there. That's my personal preference, you know.
Like a little shrine.
Yeah.
All the projects which failed.
You know, I found once like a network router or some kind of. I found the iPod from like 10 to 15 years ago. In school, we had like first touchscreen device, like iPod Touch or something appeared. It was super cool. And then I found it out. It actually turns on. It powers on. It
still works.
It works. But it was like, yeah, well, you can see nothing works on it. Like Apple has totally dropped support. You can still connect to internet. You can barely browse something. No SSL certificates on browser, but it still works. And then I was like, okay, so I have this gear now. I can't use it anymore. So I was like, I don't need to collect and store.
Do we have some kind of LT, like long-term support, LTS? Do we have a commitment to support the device for a specific amount of years?
Well, I don't think so. It gets more and more popular to drop support. I remember that companies who told about their fails were telling about trying to support something super old, like 10 years back. Like still like whatever you released then in 10 years back, it still needs to work. Then it's super painful, I guess, for the company itself. That's why it goes more and more towards this. One other thing is that you can't fix or repair anything. I think here in Baltics, our older generation people still live in these kind of,
we like to fix things,
reuse
on
things,
our own.
fix, yeah. But now you can see that, for instance, we need to open a lot of phones for the performance testing. We need to basically disassemble them, take out their real batteries, and then trick them to use this battery monitor software, yes. And there you can see that 3 years ago there were still phones where you can change battery yourself. Now you can't. Now it gets closer to 2-year warranty, and then you can drop it out. The other thing where IoT is also a field, it's like industrial things. Those things I would keep in house. Yes, that's there is a term industrial IoT also. So they're the same thing, but the gear is much more expensive. You know, it costs 10 times more. It doesn't have to be as performant, but it has to be durable and last much longer. Yeah, for instance, I get this robot, yes, which is like ABB robot from 2004. It works the same as it worked, yes, because it's built to last longer. Well, it has like, I don't know, 100 megabytes of total hard drive, but I don't care, yeah, because it doesn't need much space, but it works. Well, industrial gear in that case is something that is like built to last longer than consumer gear.
At what step does the hardware testing start? So for example, if I build this any kind of gadget, right, anything that needs hardware testing, when should I start hardware testing? At what step?
I really think it's at the very beginning, because if your hardware is bad, it's not gonna work, and you're not gonna know it's not gonna work if you're not gonna test it. So
it's not like waterfall, right? You create the software, then you create the hardware, and then you put software on the hardware and expect it to work at the last stage, right?
yeah.
And if I remember correctly, when you have a hardware and when you have a prototype, right? So probably you can test when you have a prototype at least, because if nothing is working, that's too early. But then even if prototype is working, you still have to change it, if I remember correctly, so that the manufacturer can manufacture them easily. I mean, you might have an awesome prototype, right, which is smooth and stuff, and then you just find out that the plastic machine cannot make durable plastic in that form, and you need to change the form. If you change the form, the battery doesn't fit anymore.
Exactly.
And then you need to prototype again and again.
Well, the best thing is to test as early as possible. Yeah, that's kind of as we talked about devices that are close to market, and then you realize the flaw. It's too late. Yeah, of course. Yeah, in hardware you have some kind of firmware. Then there's some kind of operating system which runs the software, for instance. Those two things need to be tested together as soon as possible. What is done for that? So when we don't have hardware, we can emulate it. When we don't have software, we can approximately imitate it, and then we can do unit tests for send them separately, and then do an integration together. Yeah, so that can be done, and that is done already in the industries. Well, we kind of more or less test devices that are already pre-made. At least they have went through most of the stages of early development when we get to them. And then we also sometimes see that, okay, there are a lot of sides involved, that software side, hardware side, there are teams and different companies, and then the QA sometimes is in a position to communicate to those sides, yes, like filing bugs and then discovering. What QA needs is to be able to understand if it's a hardware issue or software.
Oh, so I found a book, it doesn't work, and one team says it's not ours, other team says it's not ours. Well, there are only two teams, someone has to fix it.
So someone has to, we have to usually understand where's the problem. Either it's in the firmware. So for instance, firmware you can get the next day, but hardware you will wait for maybe months, maybe weeks, and depends on their kind of capacity of producing more. Yeah, we tried like with these gateways, I guess. We tried Artūrs particularly testing like firmware, setting it up.
Yeah.
You can tell about
There
that.
was the case when we had a firmware problem. Basically, we connected two devices, but the protocol said that it's up to 5 devices. We can connect actually up to 5 devices, but there was the limitation of, from the firmware side. So we actually reported back to the manufacturer, and they just created the new firmware. We implemented it, tried it out, and it actually worked. So.
And firmware and software, what's the difference?
Software and firmware?
Yeah.
Basically, firmware is what runs the device and how it's gonna work, all the protocols together. Like we have specifications from the protocol side. Let's take, for example, MBUS protocol. You can connect up to 200 devices, if I'm correct.
Yeah, well, the difference, I guess, with software and firmware is that firmware is like embedded in these chips. Yeah, and the software we consider more or less like already some applications or something, some extended software. I think it's all software, but of course, if we talk about like terminology, I guess that's what runs on the chip. In basic term, in layman's terms, that is firmware. Yeah.
And what runs on firmware is a software.
Yeah, basically, yeah. So that then you see, yeah, like as you said, Artūrs, like the problems seem to be maybe software, maybe hardware. It turns out to be this underlying issue in some kind of firmware on the chip, yeah. And sometimes those devices get so complex, several chips, each of them sorts different problem. Like one is responsible to communicate, one is responsible to calculate the data, another one just to communicate with the SIM card, another one to communicate with the meters or something else, yeah. And then we need to kind of understand how it works, and then we can, play the game. If you know the rules, you can play the game.
And
you can try to cheat.
Yes.
Exactly. And then as a testers, our task is, of course, to cheat it, know the rules as soon as possible, and try to break something.
A really good concept. Some time ago, we interviewed a specialist which were making satellites.
You can find that video attached to somewhere here, if you want to see that.
Oh, that's nice. So they, were building satellites, and it's really hard to do hardware testing because it's expensive and very late in the process. So they used what they called a digital twin, where they would put a digital copy and try to test it. Do you use anything that alike for hardware testing?
Actually, we don't use that for testing yet, but we have customers who would be interested in testing digital twin. It's a very interesting topic, like metaverse. Sometimes people who build these things, it's hard to define what they actually are doing. If we boil it down to actual technologies, then we can talk about something like a simulation. Yeah, but the difference between like digital twin and simulation is that you kind of build simulation, you simulate, then you build a real thing, and then you throw the simulation out. But here it continues to live. Yes, the simulation continues to live when the real thing starts to send the data to it, and then you can attach AI, try to simulate it first, and make the next iteration of the real thing better. In this case, for testing, it's usable, but we don't quite test it. We were offered sometimes to test something that is called digital twin, and what I see is everyone interprets it differently. Digital twin can be something like, any copy in digital world of something real, yes? It can be a house, it can be a small device, it can be robot. With simulations, we are familiar long time ago. Simulators, emulators, everything, yes? Every mobile platform has a simulator or emulator.
Yeah, basically Android Studio emulates Android.
And you can just create that copy already. Here we kind of believe in testing the real device, of course, because that's when it's going to be used. Often we do tests on both the simulator and the real device, so we can compare how they behave.
That's another level of abstraction, right?
Yeah.
If something is not working in simulation, so you have one company, other company, and then is the simulator really telling me the truth?
So if simulator simulated on software works, then we blame hardware.
So when you perform hardware testing, you probably want to have it iteratable every time when you have a new hardware or software or firmware in order to test if everything is working as expected. So do you do automation for products? Yeah,
as I mentioned about hardware testing, we could split those projects in three kind of severity levels of involvement. The easiest one is like a pilot. Shortly test something, provide some feedback and insights about what's your experience with it. Then it's not beneficial to automate it yet. You do it maybe one time or two times, then you do this cycle, and that's it. Automation is a bit next level of involvement, and it also is more costly, because if we kind of sign up for continuous involvement model with the customer, then it makes sense to automate, definitely, because if we are going to do it next year, and also if we have a contract for more years, yes, then it makes sense to automate it already.
So basically it makes sense to automate if the process repeats. If the process doesn't repeat, it's too much effort.
So, for instance, some kind of new standard. Well, let's say we are now in the development of 6G networks. Yes, if the vendor is asked to do testing and the standard is still not mature itself, it will be quite logical that the testing will repeat for years until it gets done, and when it's released, probably, well, it might stop. Yes, if they are not continuing to develop it. But yeah, things like that can be continuous. But some other things just are just one for short time, because the company also wants to quickly create it, and then we'll see. Yes, maybe the next version is a different. If it's too different, then all this automation is kind of, you throw it out and start from new. Yes, you start the version 2 and that.
But if you don't do automation, that means that every time when they update the software firmware, they probably don't know if it's actually working still.
Well, yeah, what we do with hardware is that we try to automate this laboratory equipment. So then we can try the same thing after a while. Yeah, we can repeat the process again. Actually, well, when we reach the right conditions, when the automation works as we want, and that's kind of 80% of time 20% you spend to automate it, and 80% you spend to make it stable. Yeah, that's kind of the rule
really
of
good.
thumb.
Like flaky tests.
Yeah, so this automation.
I need to put this on my fridge.
This automation you need to repeat, like you're doing scientific work. You write down every step in your kind of dictaphone. Yes, you need to precisely kind of do it and make it repeatable after a year. Maybe someone else, not you, is going to do that. So yeah, in that case, yeah, it makes sense to also automate. But what we try to do is here we try to automate per laboratory basis, so we can quickly create automation for something that is inside there. It doesn't matter what was there. We just automate the process itself, just like cooking something. Yeah, you have the recipe. Let's cook it with this temperature for that time, or we set this particular network condition for that time. And then, yeah, based on test plan, we can repeat that.
I see. So we need to update our question, because, like, is it worth to automate a hardware? Probably it's more targeted question. If you are a company which is producing something, then you should. Now you are a company where someone comes with testing, right? And you don't know what you will have to test and what device to test, and maybe the client will leave and whatnot. But you have, your product is your laboratories. So you do automation in laboratories to, I don't know, if we use your cooking example, so it doesn't matter if I cook chicken or pasta, right, the microwave or something, it still works. So that's your laboratory. So you are doing automation, that part. So can you tell us about that? Like, what kind of automation can you achieve? But this is probably a very broad topic. So let's just keep it up to one example. So take some time and give us an example of what can be automated in the laboratory.
So yeah, for instance, my experience in software testing, in my experience, at some point, like when you reach certain, like you work for a certain level of years, you can start to think about creating your automation framework. I guess at some point that's popular, like just like let's open a bar, yes, or just like ideas like
that's
this.
funny because I'm starting to get those thoughts.
Yeah, so that's actually I had this opportunity to build a testing framework for one of our customers, but that was proprietary. And then in test develop we decided we need our own kind of test framework. Okay, what will it do? Yeah, it will be basically like an octopus. Let's start with software. Let's cover Selenium, Appium, yes, web, mobile, API testing services. And then we decided, okay, we're talking about this end-to-end concept, IoT, yes. There is a device, there is a cloud, there is services. Okay, parts of that already can be used. All we need is drivers for these physical devices, for these laboratories. And, last year we started to add it. So we have this crazy guy, Alvaro, who built his own framework, I guess 2 frameworks. He will tell you about them, about audio video testing.
Or maybe already did, depending on when this
podcast
will come out.
This episode might come
that's about,
before or
I'm
after.
advertising his podcast, yeah. So he's behind this idea, but we went together to extend this octopus with the hardware part. So you can have drivers to automate like robot, for instance, or what we have is currently we can automate all these 3 laboratories, like the network testing part and all that. Each of them separately works as a, like a module, like a library. You can use it standalone to just run this setup. But if you need to control device while it's in the box, you can just plug it in and write a script that will do in steps. First, for instance, shut the door, disable network, enable like latency network.
So setup.
Yeah, and then you just run regular application automation script on the phone, and then you see the scenario, yes? And that's kind of the ultimate end goal. So that's why we kind of started to create this kind of octopus. I would call it like that. It's actually called TestRay. Yeah, so it's open source thing. It's a Ruby-based library. You can try it out yourself. And then, it runs on the boxes that we have. And it runs in audio-video setups, in location setups, and battery tests.
So you can not only write automated tests for software, for hardware, but now you can start automating laboratories.
Basically,
pretty cool.
Basically, putting it all together. Yeah. So with the years of experience that we have with these individual laboratories, we kind of started, of course, to automate them separately. But then, of course, the logical decision is somehow, and also it's customer driven also, like customers say, I want it all. So what's your answer here is that, okay, here's your setup, yes? Like you open IKEA menu, yes? You select certain boxes, and then you kind of formulate what's the physical thing. And that's, I guess, the answer also to some wider topics like digital twin or metaverse. If we boil it down to technologies that we currently have, that we can use to build it, then we can understand how to test it. Okay, it will have billing, yes, it will have services, it will have an app, it will have something that we can already...
There is no magic in the world, everything is already done.
Yeah, there's like saying like about cloud, it's mostly Linux servers. Yeah, that's...
True.
Yeah.
That's,
it's just under the fancy name.
Yeah.
When the devices comes out into the market, we have some kind of a testing done, how long we're going to be lasting. There's some, for example, for electric vehicles, there are like VLTP standards, how we do testing for how much miles or kilometers they're going to be lasting. In reality, those numbers usually are way bigger than the reality checks. How are those tests done, and why they're so different from real world scenarios?
If you talk about like applications, like software, usually when we see that, for instance, how long this phone will last, like the battery will last on that app, that we do test. Yeah, we have specific gear where I think I mentioned it. Basically, disassemble this smartphone and attach to it specific like laboratory equipment that imitates the ideal battery. And in that case, it never drains, but we measure how much energy it consumes. And then we design specific test cases for that product, for that app, and then we run them and measure how much energy it consumes. And we can easily calculate, let's say, by just physics. Yeah, you see that it consumes this amount of energy. You see battery capacity. You can calculate how many hours would it last on that scenario. And then looking at the hardware again, if that runs on a smartphone, usually the top platforms like Android and iOS have some kind of benchmarking we can access. For instance, on Android CPU data, we can use this software that returns logs from device, and it shows you like times when specific modules on phone were active. Yeah, like how long it took, like screen activity, for instance, CPU activity, Bluetooth, radio, when was it active, and we can do analysis on that to see where it needs to optimize. Yeah, so maybe it doesn't need to do some things extra, so to save energy. The problem here is for IoT devices, it's also a mobile device, but that's a bit different. You need to go into this firmware, understand what the firmware does, and usually, the vendor doesn't provide that cool way to get logs out of it. So you need to kind of understand where this energy is drained. And I guess there Artūrs already started to tell about when we have communication modules inside this onboard. Yeah, we could kind of look at device from an anatomy perspective. There's one firmware that is, let's say there is some kind of STM processor that is, basically it's doing some logic there to send the data to ask for the sensors, and then there may be some co-processing chips or some kind of chips for specific protocols that are actually talking to devices. Everything drains energy, and we need to understand when they are up, we can measure what's their temperature when they operate and all that. Yeah, so that's a bit of electronics analysis itself.
We did some radio model testing. Basically, we opened the gateway and soldered to the pins of the radio model and connected to the computer. And with the help with software, we could actually analyze what happens inside this radio model and get in-depth analysis. And from that, you send it to the specialist, and he analyzes the AT commands and what network problems do we have. And that radio model is about, it comes to network testing. We had network issues at the time, and with that soldering, we really just directly soldered the pins to the pins of the radio model and got in-depth analysis from it. So I think it's pretty cool.
Oh, so you kind of hacked the device to get the
Sometimes,
data.
yeah.
Sometimes you have to go to those measures when nothing works.
You don't give me the information the easy way.
Yeah.
Yeah.
I'll get it the hard way.
I'm gonna cheat and get the hard way.
It's kind of a problem when you don't have debugging ways how you can debug your hardware, because in software it's easily done. You can at least on system line out or something system output, right? To give out something like signals information. With hardware, if there's no way to do that, it's quite difficult.
And it's not one hardware component that, in one place you don't get it. Maybe this chip that commands the radio module was doing exactly as written in datasheet, let's say, yes? Well, we can look at this electronics as quite standardized. For every component you can find a datasheet and kind of imitate what the processor would need to ask for the radio module and all that. But it turns out maybe sometimes the problem is in the radio module. So maybe the processor, it logs out something, but it's not meaningful. It doesn't log anything about what the radio module sees when it connects to mobile network, yes? Sometimes it does, but sometimes it's not enough, yeah? So in that case, we can investigate the network part specifically. Sometimes it's about other modules that manage the power of it. Yes, maybe there's a backup or something. Yeah, like.
So for IoT devices, if they are connected to the cloud, that means that there is a connection. And if there is a connection to the internet, that means that someone can use that to gain access to devices or maybe to the cloud itself. So I guess there is a specific security layer for IoT devices.
Yeah, basically that procedure is that you have the device, you connect it to, let's say for example, MQTT broker. That's standard to the protocol, and we use it. And after you connect to the MQTT broker, you have the choice. You can use the default MQTT broker, or you can use SSL MQTT secure. And basically it means you generate 3 certificates, and without those certificates you cannot connect to the MQTT broker. And if you cannot connect to the MQTT broker, you basically cannot see the data. And after you connect to the MQTT broker, usually there comes a microservice where you decode the data for understandable language to the cloud, because usually, in my experience, IoT devices send some JSON type of payload, and you have to decode it in your microservice, and later on you implement that microservice in your cloud.
Sometimes it doesn't. Sometimes it's just transparently sending whatever the sensor sends. It can be binary, It can be some kind of already encrypted thingy. Yeah, and then in that case, you basically make the device as easy as possible, but then you offload it, but you put the load on the service side to decide how to decode. Yeah, so you decode the communication itself, then you get the message, it's again encrypted, then you decrypt message, and then you get to these numbers that you want, and depending on the format as they come in.
But each layer of security, I guess, adding on consumption, the power consumption, right? With that place, that SSL key, like you only need private and public, right, for to be stored, and then like encrypted, decrypted, well, probably encrypting only, and sending out a signal. So it's maybe not that like power consuming, but anything else extra layers?
Well, in my experience, the default without SSL MQTT drains a bit less energy. But with security, it drains a bit more. It's not a significant amount of drain, but it's just a little bit.
In percentage, maybe like 5%.
I would say it's barely 1%. Like it's really small, insignificant difference. And when we actually measured it, it actually didn't matter. Like from the battery draining side, but I mean it's a cool thing to know, because when we need to provide detailed analysis for battery testing, it's good to know how much our device consumes the power.
On the other hand, that actually impacts network. Yeah, it gives a network overhead. Of course, you have to do handshake. You have to exchange those certificates. You have to send really that content out of your basement uninterrupted to the server, and then you can only establish secure connection. And if your SIM card is on like high data rates and quite expensive data, then it's important. Yes, well, from energy perspective, might not be that visible, but then what they do usually is like either your device pre-encrypted it, or you negotiate with the server for the security layer, yeah, and then you establish a secure tunnel, yes, or you just have a key or something on your specific device. Usually, you know about OTA, like your device can be updated over the air, so that can be compromised, of course. But that usually also happens, like you get some kind of factory key, so you first time go there to this service. It gives you the next key, and then you get the real one, and then you work on that. So basically, IoT platform is managing your device. So when it sees you first time connected, it starts to manage it. And then you can access everything from device on the platform, and also you can control device and update it over the air. So that takes energy, but talking about energy, when device sleeps, it can't do anything. Yeah, so
we need to wake him up.
Yeah, the tricky part here is to understand if device is dead or it's sleeping. You know, it didn't send you data Tuesday, you are waiting it on Wednesday. If it doesn't send, then it's probably dead. Yes, but it might be that it didn't manage to send it. Yeah, and you need to understand you can't do anything with it when it's sleeping. It wakes up on certain schedule, and then you interact with it only. Yes, at that time you just stop the communication and send specific packets so that it knows you can update. That is just interaction between platform and device. When the secure layer is established, it's okay. I mean, there are standards that quite hard to break, cryptography algorithms. Yes, and those are applied to most of the industry. But the tricks here start when we actually think about what the vendor said this device can do versus what our customer, for instance, wants to do with it. When they say it's designed to work for 10 years, with small letters, says when you power it up once a day. But then we want to do it every 15 minutes maybe. We want it real time, yes. We maybe want to use it for a critical infrastructure where it needs to be always available. And then this device needs to be basically up all the time. And then it breaks the rules. Yes. Yeah,
Usually in those use cases, you search for external powered use case. So
yeah. Or
you're
just
not sticking with the
provide diesel generator
battery oriented devices, because it's not always the best case.
So if you have this water meters, can you create some kind of like propeller which would be powering itself through normal water flow?
While the water is flowing, the device is
just
working.
like we don't need an internal power source then. But
Actually,
I mean, I think it's quite possible, but no one does.
I'm going to do a patent for this one, so don't worry.
so
It's taken.
what we were doing with this is actually we were emulating some sensors, like not those ones that are sending the data, but for instance, we had some sensor that just emits emergency condition. So we take some regular Arduino with relays and just imitate this impulse, and then we test that the gateway can work. And let's say the gateway had like, I don't know how many, 8 inputs for different conditions, and then we were just imitating with very basic hardware. But yeah, that part again is just creativity of the engineer. Yes. Of course you can attach switches and do it manually, but at some point you want maybe to automate it, and then you are starting to figure out these tricky ways how to imitate this device. Yes. Like I guess for water sensors it was to attach magnets. Yes.
I heard about that trick back in the day.
Yeah.
So that I just never understood what did they do.
Well,
let's not
keep
do
it.
hacking here. Where do you learn that? Oh, from podcast.
if we actually talk about the meters, there are, like for water, there were at least 3 types. You know, in your regular apartment, you will have some kind of legacy meter, right? There's some spinny thingy on it. Then you can attach this device, which is kind of reading what's the spinning rate and just calculates the consumption of water and transmits. Usually it's Bluetooth. So there's like still a person comes but doesn't need to write on paper, just scans with NFC and just gets the reading. But if you want it further, it's this VM bus, which allows you to transmit it further. And if there is in a corridor a gateway, it can pick it up and send later. And then you can buy really like a water meter that already has a SIM card. Like it's in factory built in. You can't even change it. It's just a built-in SIM card in special format. Yeah.
It just sends the data straight away.
Yeah, so that has everything in. You can't compromise it. Potentially you can, but it's kind of sealed in epoxy and everything. Yes, so if it's broken, someone will notice. Yeah, then those actually, I think there's a company in Lithuania producing them. Axioma.
I think Axioma.
So yeah, there's like a cool stuff. So I see that people get innovative also with simple things as that. Yes.
I mean, it's pretty cool that you can actually take one meter and you don't need to use very many infrastructure devices to get the data. So.
And what about eSIM, electronic SIM? So you don't need to have a physical one. Maybe that's going to push out all of the SIM cards eventually, right?
Yeah, actually there are platforms that offer you like a wireless thing about imitating SIM cards. Yes, because you need a lot of them in IoT scenarios. If there's a factory, also factory devices need them and so on. Yes, so you somehow start to manage this part of having a lot of SIM cards, paying for them. You know, you want to get a better deal, obviously, and then it's a good choice. Yeah, to actually use virtual SIMs. I'm not sure about these water meters. I guess they had some physical.
No, they always have a physical pre-built SIM inside them.
So that's a challenge for the telecom company. Yes, in every country, the telecom company needs to support these standards, like not only 4G, 5G running for higher data rates, but also for machine-machine. So it needs to have proper coverage, enable it in towers and all that. So that's kind of a topic for these kind of providers. Yes, a challenge to support all this. And
do they have specific phone numbers as well? Can I call them?
Actually, that's a separate thing. You can have a device that has only identifier, like SIM card only has identifier. Yeah, machine to machine maybe has some kind of address, but it's not like phone number based. Okay. Yeah, that's a different scheme.
And I read somewhere that Lithuania is planning to turn off the 3G network. So
yeah, same here.
So what to do with all those, if someone has an IoT device who uses 3G, or it's not popular and not many devices use it, or none?
I guess there's some kind of regulation coming in, so that also in Latvia the same thing. The companies are starting to get interested in expanding in narrow band and also all possible other ways to get out of 3G. There are still like devices that work on SMS. That's still a thing. Yeah. So, but that whole thing, that's a legacy. That's like for this early adopter problem. Yes, you had it built back then, and now you need to upgrade it. So that's kind of another challenge.
I mean, there are still use cases when you can use them, like if it works properly, if your requirements allow that. So, for example, we use narrowband when it's.
What is a narrowband?
Narrowband.
Is it like 2G or 1G or 0G?
It's based on LTE. Yes, it's.
So it's 4+, right?
Something
4G
something
plus.
Well, the bandwidth is smaller, but the protocol allows you to make the connection more persistent with smaller data, but making sure that they arrive. Yeah,
so it's not like with 4G. I remember, like, if you always go to some parking lot, zero internet there, it doesn't go through, so that this protocol will go through.
Yeah, basically we use it in a basement where we have no 4G connection there, but there's a probability that narrowband will do the work, so that's when we use it.
And maybe it's a good place to ask about 6G. So you mentioned that you might be working on it. So what's maybe coming with that?
I mean, I just mentioned it as an example, right? I don't see any specific example yet on the horizon, but I just took it from actually experience of 5G. And with 5G, it was quite similar. It was announced a while ago. It took years for it to get mature, but until then, technology still kind of adapted, changed, and it is a good option to collaborate in like longer term project, because that requires iterations of trying, testing, repeating, design again, and so on, until it matures. And then we will see how it looks at the end, because with 5G, what I saw like couple of years ago, they showed like a piece of paper where it can't go through, and now what we see, it's already on our phones. At some point, that will get to a standard. Not sure if it's gonna use satellites, although we have some experience with satellites. We have here also Starlink, so we can just connect to it when we need to test. Prior to that, we were using specific conditions on router. So someone asked, "Hey, what's the satellite connection parameter?" We said it's like delay is like super huge. It's like several seconds. So we can imitate it, but now we can try it on actual one, and it's pretty much normal internet. Yeah, it's not
really? So they decreased
What's a ping? What's a ping for Starlink?
I think we have like some kind of specific blog post for it. I just don't memorize the parameter.
But is it like hundreds, tenth?
Can you play games?
I think you can. Yeah, latency.
Actually, you can.
Latency for any wireless thing, even for 5G, is quite like questionable. Yes, in the real world conditions. But the bandwidth is quite normal, and it's like interesting technology. And I'm just speculating, what's the 6G? Is it going to be in every head or from the sky? Satellite, yes. Well, it's when
humans gonna be the walking antennas.
Yes.
There is a science fiction book where that is the case.
Yeah,
I can maybe mention it. Hyperion Cantos. There is a book called like that. A very good one. So the humans are actually the emitting force, but I cannot tell anything else because I will spoil that.
Yeah.
Okay.
In Matrix, humans were like batteries. So humans are doomed to be a tool.
They are going to be used at one point or another. Some time ago, when I was working, and I had my colleague who went to the company who made like a device in the home, right? So they were like a manufacturer, vendor, right? And they sold the devices, and they need a software tester to do hardware testing inside that company. So I was interesting, because it's a device, I can go outside and stuff. But my colleague told me this, and now I want to confirm with you if that's true or not. So the statement was that testing hardware for a tester is like a suicide for your career, because what you will learn there will not be adaptable in other companies. Meaning, if you will learn to test that device only, if you will move to test other devices, it will be completely different.
If we look at how people, like employees of Tesla, usually you are being hired when you at least get certified as a tester. So you get ISTQB certification, during or after your internship usually, and then it means that you already got through this generic part of, you get this qualify already as a tester, so that doesn't matter which project are you going further. Yeah, and I agree, every project has a specific knowledge. Some of this is you can't even expose it, but that is your experience. Yeah, and as a tester, if you follow the testing guidelines, I mean, you still have learned something, and it's still applicable to other fields. Of course, it depends how specific and how much you change your work field or something. Yes, but in general terms, I would not agree to this. I would say it depends, of course, how you test also. But if you have already learned something, I guess you can't lose that. Yes, that's your experience. Well, for manual testing of hardware, it's not about pressing buttons here. It's about also doing analysis later and providing your insight. So one of the arguments also pro manual testing is that we still don't, the automation still doesn't catch as many things. Well, ultimately we want to automate everything and be lazy and sit and drink coffee, right? But then if we do something, we can't lose that knowledge anyways. It's about analysis, about reporting, and all these skills are applicable to any project. It depends how you test, of course.
I agree. I thought that it's odd, and maybe but now I agree. Yes, if you do analysis work, you start thinking analytically, right? You still organize your work, you interpret your results. Okay, so the technology changed, the device changed,
yes.
The results are presented in different way, but it's still some kind of data. You still need to organize it, and you need to make sense of it.
Yeah.
But if you need to be certified in some kind of area, and you did other thing, and you are not certified, you don't know the terms, you will have to learn them before.
If you want to be a doctor after doing testing, of course, doesn't apply anymore. But if you want to go to test something else, first thing you kind of don't learn is, but what you get by doing is the mindset. Yes, the mindset of willing to break things, understanding if you like it even. Yes, like we talked about learning earlier the rules of game. New technologies come, you need to learn all the time. If you don't like learning at all, then it's a problem already in the first place. Yeah, but for me also, I'm already working for almost 10 years, and I'm learning all the time. Yes, and then I start to see from project A to project B and project C that some things, some approaches that I use still stay in me. Yes, and I just take the new one, and already there's building some pattern. Yes, I would say mindset. Yeah, and one of the things is, of course, thinking critically. Willing to break things, be the bad person that cheats in game. Yes, that's sometimes you kind of can enjoy, but you enjoy it in a controlled manner as well. So you make sense of it, and also get things done, organized in time and meaningful to the customer, not like randomly just throwing hammers around space. Yeah.
For manual testing, it's the same thing. That there's a lot of, when you move from one project to another, there's a lot of domain knowledge you're kind of losing. But you keep in mind that which helps you to do risk analysis, thinking that what can break, other things can break, because you know the software, you know the domain business. And it's the same thing. It's you move to another project, it's gone. But the skills you use to do that, they are growing. And you can get at the same level for a new project faster.
I completely agree. But on summary, that was a myth and it's broken.
Yeah.
Right?
So during your experience in hardware testing, what are the most memorable hardware-related bugs you found?
If you can talk about them, of course.
Probably the network bug. We struggled with it for almost a year, and we couldn't find the problem. As I said previously, we soldered even to the Regia model and got the in-depth analysis. Of course, we didn't find anything in there. And we just kept looking all the time. We checked all the components. We checked all the security protocols, what could be the cause, and we couldn't find anything. And we really almost spent over 1 year on it. And it came to working. It just suddenly started to working. To this day, we don't know what was the cause of the bug, but it just magically started working.
So the case remains unsolved.
Yeah, unsolved mystery.
So really? For 1 year it didn't work. It reminds me of a story like my friend bought wireless headphones, right? And he heard like a strange sound in the headphones. I have the same model of headphones, and my headphones doesn't have the sound. Those are completely new headphones. So he returned them, got another one, and there is still a sound. Okay, I say, there cannot be coincidence. There is no magic. He came to my house, no sound. Okay. We drive to his home, like connect both the headphones to his PC. My does not have sound, his has sound. Okay, maybe something in the house. Turned off the router, something. Okay, didn't fix it. Maybe the neighbors has it. We brought the computer outside, right? Still the sound. And at the end, we found that this guy has a very good hearing and he hears the coils inside.
Wow.
Because I put his headphones, I
Yes.
didn't hear it. I brought my friends, like gamers, they didn't hear it. That particular guy has so good hearing that he cannot use wireless headphones. So that was my story, and it took around 3 months. And he's like, "You all have wireless headphones. Why cannot I have wireless headphones?" So at the end he bought like wired ones. So that's maybe someone outside of his home. When it didn't work for your network, maybe someone around this office was using something for a year and they turned it off.
I mean, there's a high probability that there was some third-party work in this whole chain of unfortunate events, and how it started magically running. So, yeah, sometimes you just gotta be patient.
But just in general, as we are talking about, let's talk about quality. We don't suggest ignoring issues for a year and hoping it will be solved itself.
All right?
Now, of course, we did enormous amount of work, but
That's just frustrating. For
Yeah.
a year, everything else works, but this one particular, it would bug me to death.
there was many test reports and reporting to the right people, and there's a lot of people involved in this issue. So it wasn't just magically, but
Imagine one person like somewhere like, why are they mad for a year? It's something like issues, and he's like, oh no, and he silently fixed it.
Yep.
So,
But then
so I would say just important to stick to your job, do your job, and
Keep looking.
keep looking, keep searching, keep looking, report it back.
About patience and software, I mean, you kind of follow the technology trends, right? So maybe sometimes technology is not there yet and you have to be patient. Yes, maybe it will start working after a year because you already built something that was documented but not released. You can mention an example about like iOS problem, like about IP networks, IP version 4, IP version 6, all this. Do you have IP version 6 at your home?
I have, but I don't use it.
So yeah, it was about Apple follows it, and when you kind of build apps on iOS, you kind of ignore those warnings. But with Apple, it's like when it's warning in the next thing, it's gonna be really shut down. Like it's not like gonna be warning all the time. The next version will definitely drop support or add support.
Deprecate it.
Or add something new or something happen. Yes, and if you ignore warnings on there, then you probably get screwed as a developer. And when I saw a case when adding too soon technology went sideways is about IP version 6. I mean, that can impact things like when it was added too soon, then suddenly the product stopped working for a while, and it turned out that you're just too closely following it. But if you wouldn't do that, you'd probably be okay. Yeah, so it's kind of like looking at warnings versus errors in the building process is like walking on a thin line. If you choose to be on one side ignoring, it's bad. If you choose to go too fast, it's again bad. Yeah.
So can you explain me what was the issue? So they announced that they're going to support IPv6. The developers in their app implemented. It was warnings because it doesn't work, right? So they ignored
and then you kind of start to use, and then there's some kind of other issue related to that technology not being ready yet at that point. Yeah, so it can be different thing like that. Yeah, so it's sometimes even like hard to follow that all what's going on with technology. especially if you're working on layers and layers and layers, and then are vendors and vendors and vendors under that. Yeah. Well,
In software, it's libraries, right?
it's
libraries,
libraries,
multiple
and
yeah.
libraries
Yeah.
on top of them.
But it's a cost of being early adopter, right? It's
Yeah.
the same thing that you mentioned before.
I think I know like cases about ATMs in USA. Like ATMs in USA were using these magnet stripes. They are still doing because it's early adopter. Like here, we are already using NFC by default. I guess in rare cases someone uses magnet. Yeah, but that's one of the cases, and that's about also IoT and smart cities and all that. So you sometimes build a technology that is not ready yet. You kind of pay the cost. Maybe you will need to update it, yeah, or maybe you will build it in a big scale and need to upgrade it. It's again expensive thing.
It's the same with the internet speed. Like Lithuania, Latvia, Estonia is among the countries with the highest internet speed.
Yeah.
Because we got it later.
Yeah.
And it was cheap to build.
It was
fast.
already mature technology, yes. And then now we are starting to join these early adopters of new technologies and also in networks. And then it's a bit risky, yes. So it's up to everyone to decide when to adopt the technology. Either to wait when your like neighbor has it, or just buy yourself, and maybe after a year you'll find a bug and need to buy a new device. That's a risk always.
But there are lots of advice on internet, like never buy like a car which is just released, because they will release like a facelift in 2 or 3 years with the bugs fixed,
Yeah.
right?
And then in 2 or 3 years, when you release a new one, so you will never buy a car.
I think the facelift doesn't count like as
It's
a new
a
version.
midlife upgrade, so it's a
it's
midlife.
upgrade usually to fix some kind of issues, like I don't know, falling the button or some. But that also sometimes introduce an issues if they do a change. But that's so complicated. You need to do lots of research, and then at the end you still have to make a decision. And if something doesn't work, only you made the decision, and there is no one else to blame.
Well, that is a responsibility also in QA process. At some point, you need to make this decision whether this thing goes or not, and of course that involves like different things. Like, is it important? Like, what's the risk? What's the impact of it, and all that. Sometimes it's better to stay back. Sometimes it's just you get pushed by a lot of sides and all that. But yeah, that's one of the, I guess, parts of work for QA. At some point you get blamed for that.
You always get blamed.
Of course.
You need to learn to be bad news giver, because
Yeah.
the QA never comes when something is working. They always come
Exactly.
when something is not working, and you need to be fine with that. You need to be fine that people might shy or boo every time you enter the room because you bring the bad news. So I think we covered what we wanted to cover about the hardware testing. So thank you, our guests, for the insights and answers to our questions.
Thank you for coming to Riga office here and in this afternoon. Yeah, I guess, thank you for coming here, and it was a great pleasure to talk about testing and experiences and building your own frameworks.
Basically, we briefly communicated, and it was fun. Thank you.
Thank you.
Thank you. And thank you, dear listeners.
Bye.
Thank you. Let's make it. Let's
Sounded
make it
like you're
less
breaking
awkward.
up with someone.
I would say let's leave this.
Do you like this?
But come on, it's like always a bit fun to have to see like,
Someone laughing.
Every time this thank you is so awkward.
Yeah, that's true.
Sounded like a breakup. We talked, we had fun.
It's not you,
It was more-
it's us.
But
Yep.
we need to finish this.
Okay.
Yeah.
But so let's leave it or just write
Let's
it
leave
down?
it. So-
Let's leave it. Yeah. Yeah.
Jesus.
You want to repeat it?
It's fine.
Like,
We
I
can
thought
repeat
it's,
it.
I mean,
It's professional.
If it's good content, why not?
Yeah.
No?
Well,
I mean-
it was funny for us.
let's
so-
just in case record another one,
Okay.
and we can then choose. Right?
Okay.
Yeah.
The
So-
official.
Need a calm face, right? All right, so thank you, our guests, for this nice talk. We covered hardware testing. It was insightful, and I learned new things and terminology, which I will have to Google if I ever want to understand them. So I hope this was useful to you, dear listeners, and you learned new things and maybe have new ideas to consider or ponder on your own. So thank you.
Yeah, thank you,
Thank you very
gentlemen. Thank you for joining us here and actually inviting us to be hosts. So, guests to our host event.
All around fun experience.
Highly recommended, right?
Highly recommended.
10 out of 10.
Nice.
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 All right. So on this note, thank you.
Thank you.
And goodbye.
Bye.
Bye.